All right. No worries. If you have to step out, no worries. I try not to call on people specifically or anything during this. You know, that seems always seemed a bit mean for the people who just want to, you know, just want to be left alone and learn. So, okay. Today we are going to be talking about, let's see what I have down. Although I know what I have down, but I'm double checking what I have down. So share screen, and we are going to look at course modules. So we are now in module 2. So be sure to read the textbook. And if you need more supplementation, I did videos on all these sections. This is a playlist, by the way. So hit the top right if you need to see this. Right, top right, which talks about different things, the different things the chapters go over. Ideally, I would like you to have the textbook readings done by Friday so that you can have that ready for your labs on Friday and Monday. So now it's a bit weird because of that because of the way that it you know, it was a bit weird. We have Monday, Friday labs and Tuesday, Thursday lectures, but honestly, it works out now that after we've had MLK Day, I swear, because now the way to think about this class is that the class content we start delivering content on Tuesday and Thursday, and then your lab on that content is on the Friday and the following Monday. So, so the lab will always be over stuff that we have just covered in lecture. I will be posting the first quiz this weekend, or sorry, later this week. It will go over assignment statements. So how do we use variables? And I'm going to cover that in a second. It's going to go over basic calculation operations. And I'm thinking about adding a couple of questions just based on the syllabus. And there's one history question on there. It is open note, open book. The only thing to keep in mind is that you can't close your tab or move, you know, you can't close your tab. So if you did something like this and reopened it, right, it will lock your quiz. I think I'll make a mock quiz and show you on Thursday or something like that. But if something happens, then let me know. And I will, I can unlock that quiz for you. Now, while I'm assigning this quiz like on Thursday, here's what you need to remember. Actually, yeah, because I got to change this due date. It will be due in about a week or two. So you'll have probably a week and a half after I assign it. So you'll have plenty of time to work on it. You just got to find a 45-minute block of time to work on it. Okay, you can do it at your own leisure. Make sense? It's a take-home quiz. It's just an electronic take-home quiz. Okay. So they are based on the textbook reading primarily, which is also stuff I cover in the lecture. The lectures and the textbook reinforce each other. Okay. They kind of go hand in hand is the point. Like today's exercise is going to be a bit more, it's going to be a bit more graphically exciting version of what's going on in the textbook. So speaking of the textbook, no, that was last semester, so I just didn't update the day. I noticed that. So let me go ahead, watch this. Nothing to see here. You know, I was just testing you. Whee. Okay, it's gone. So you will know when it's due when I make it go live. But it will be due. You'll have at least a week. Like I'll post it on Wednesday and you'll have at least past. So I'm going to post it on the 19th and you'll have at least to the 26th to do it. Make sense? Okay. All right. So let's talk a bit about Python. Okay. Yes, that's correct. Okay. So we have two basic modes of using Python right now. So we have, rather, I should say, two modes of interacting with Python right now. Okay. So our first mode is the interpreter, and the second mode is the script, which is the or the script writing, which is what you'll most usually be doing. But the script this over here, essentially you enter in one command at a time and the computer processes it. What's the use of this? Well, it's an extremely powerful calculator. That's what's useful about it. Whereas this allows you to basically write all your commands all at once and run them all at once. And your computer will run them in order. So it makes a full script for your computer to read one direction after another, like a stage script. But let's talk about this one today because this is useful for just testing out stuff. So what do I mean by the most powerful calculator or an extremely powerful calculator? Well, it can do all the kinds of things you'd expect your standard calculator to do, like addition. 5 plus 5 is equal to 10, right? No tricks up the sleeve there. 2 plus 3 is equal to 5. 2 minus 1 is equal to 1. 2 minus 5 is equal to -3. So exactly how you expect. By the way, if you're coming from another programming language, guess what? Python doesn't care about how big your numbers are. It just doesn't. It will tolerate, however, it tolerates numbers that are arbitrarily big. And it does it, so if you're coming from another programming language, that's something to worth note. You don't have to worry about ints and longs and stuff like that. But as you'll discover in the textbook, and as I'll cover in the textbook, there are different types of data that we work with. Okay. The two numeric types are, and we work with three a whole lot in the beginning, which is this first numeric type, which is integers, right? Or we call them int for short. So what is an int? An int is any number that is positive or negative, and it's a whole number, or 0, right? Whole numbers, meaning they aren't fractions or anything. So anytime that we have a decimal point, we're no longer dealing with an integer. But otherwise, these things, just nice big numbers that most humans can, nice numbers that most humans like dealing with. The kind of numbers that you can use fingers to count with, right? Like 4 plus 9, right? Gives us 13. We can use, basically, if you can use your fingers to count with it, assuming you have lots of fingers, that's an integer. Okay. If you have a decimal point, we call that a floating point number, like this. Okay. And again, I'm just going to briefly cover this because this is in the textbook. Okay. And you can't really add things of different types together, but Python will quietly turn this 6 into a 6.0 for you. And so that it can add a float to a float instead of an integer to a float. It's just a quirk. The one thing that I should alert you that is not expected behavior, by the way, is the following, right? Which is that if I want to do so we've got 2 times 2 times 2 times 2, which is 16, right? This is the one behavior in Python that is counterintuitive, okay? That's 16, right? Okay, that is better written as how? What is a more concise way to write that? 2 to the what power? Yep.
4.
Yep, 2 to the 4th power, right? So, however, if we do this, we get a 6, and that does not look right? That looks very wrong, doesn't it? This is because the following operators the following symbols are operators that you don't actually really need to care about at the moment. these are weird binary operator symbols that deal with binary numbers, zeros and ones, and they're specific binary manipulations. Specifically, this is the binary and, binary or, binary XOR. You don't need to remember those. What the heck is XOR? Also known as XOR, is exclusive OR. Don't worry about these right now. We'll get into that when we deal with binary if we decide to. But it's the important thing is that this is not the to the power operation. Python actually uses bar is shift and the key above enter on a standard US keyboard. That is called bar. It is an OR operator. It is, so this is binary and, binary or, binary XOR. Yeah, logic gates. That's right. That's exactly what these are kind of emulating, logic gates here. Why does it get 6? Because 4 plus 2. Okay, so that is an excellent question. All right. I knew I was opening up a can of worms, so give me a second. I have myself a Wacom tablet, and I have myself a cord somewhere to attach it. Because this is... All right, so I guess we're going to go ahead and do a side lesson into binary today. That's perfectly fine, by the way. It's today's lesson doesn't take too long. It's another textbook exercise. So, but again, this is kind of the stuff that the lecture is devoted to, which is interesting information that you wouldn't otherwise learn. There's a pen somewhere. Right in my chest. That's where it's supposed to go. That's an eraser. That will not help me. That's like so far off the position of it helping me. You know, I could totally blame this on a 4-year-old. It's getting close to my desk, but that would not be fair. Okay. You know what? I don't need that. I don't need that. Let's go, because I can just do this. Okay. Right. Typing. That's better anyway for everybody because my handwriting is terrible. Seriously. Let's go. All right. So in binary, the number 4 is as follows. It is 0, 0. Sorry, it is 0, 0. Let's go ahead and do 4 bits. So what in the world is bit anyway? Anybody know what a bit is? What that stands for? And it's a 0 or 1. That is correct. That is technically correct. The best kind of correct. So a bit is a contraction. It stands for binary digit. Okay. Stands for binary digit. Okay. And that's as opposed to a decimal digit. Decimal, we've got these characters, right? Whereas a binary, we only have 2 values, 0 or 1. So this is this works in a base 10 system. This works in a base 2 system. What in the world do I mean by that? Well, let's take 193. I just simply chose that number at random. We can break 193 up into its component parts, its component digit parts, right? Specifically, it's 100 plus 90 plus 3, right? This is the ones place over here, the tens place over here, the hundreds place over here. Everybody following so far? Yeah. All right. So now we've got that. So, but let's go ahead and write this in a more mathematically, how to say, concise way, or more mathematically precise for doing other things, because I'll go ahead and make this a bit more clear by adding another digit. So this would be 2000 plus. All right. So this is it works in base 10, which means each of these has some kind of power of 10 attached to it. 10 to the, and I'll go ahead and use the Python notation here. That's how you do exponentiation, by the way, in Python, 2 power signs. We'll get back to that. But for right now, let's make it human readable. 2 times 1,000. So that is 2 times 1,000, which is equal to 2 times 10 to the third. 1 times 100. 9 times 10. And 3 times 1, right? So this was 1,000. And so now we can switch these into powers of 2, which is 10 to the 3, 10 to the 2, 10 to the 1, and then 10 to the 0th, because weird quirk of math, which is that, or weird identity in math, that raising something to the 0th power gives you 1. That's just the way it works. It's the identity property there, I think. I'm not a mathematician, so I just play one on TV. So a binary number is made up of zeros and ones, but it can be broken down into the same way. Okay, which is that we have a 1 plus 0. So we have a 1 plus something plus, sorry, we have a 1 times something, a 0 times something, a 1 times something. And if I'm going too fast, don't worry, I'm recording. So I'd rather you pay attention than try to scramble to take notes. And a 1 times something. Okay, so here we go. We've got 1 times something times 0. And what is that something? Well, these were all powers of 10, right? 1,000, 100, 10, and 0. These are all going to be powers of 2. 2 to the 0th power. 2 to the second power. Sorry, 2 to the first power. 2 to the second power. And 2 to the third power. Or another way we can view that, or sorry, let's rewrite that a bit easier now, which is that this is 1 times 8 plus 0 times 4 plus 0, sorry, plus 1 times 2 plus 1 times 1. In other words, for binary digits, we don't have the ones place, the tens place, the hundreds place, and the thousands place. Instead, we go up by powers of 2. So for a number like this, where we've got 8 digits, okay, what we'd be seeing over here is we've got, let's see, we've got the ones place, the twos place, let's see, the fours place, the eights place, the 16s place, the 16s place, the 32nds place. It's fighting me. And then the 64s and the 128th place, right? 1, 2, 4, 8, 16, 32. So it's going up by powers of 2. So in other words, 4 is represented by, let's see, not this, but this. It looks like 100 because what we have here is the ones place, the twos place, and the fours place. Make sense? So 5 would be 0. So this would be 5, 0, 1, 0, 1. And I can check that, I believe, by going into here and say B101. How do I do it? Can I do that like that? I forget. Int, oh, I can just maybe do 1, 0, and then can't convert non. Okay. I haven't actually tried to do this before. That's why I'm not. Oh, okay. X base. So let's try 101. Just want to try this for a second. Base is equal to 2. Can't convert non-string with an explicit vait. Oh, okay. I see what's going on there. I see what's happening here. And let's see. Yeah. So that is saying 10, which is what I wrote there. So that is 8 plus 2. So this value would be, and we're just, so your computer can translate stuff into from binary to not binary, which is pretty cool. 5. So we can, so that was just me double checking this, but yes, this is 4 plus 1. Okay, because this is the 1's place, the 2's place, the 4's place, and the 8's place. All right, so what?
Wait, I have a question.
Mm-hmm.
So what does the B stand for?
Ah, excellent question. That's saying this is a special, this was black magic, but it means that it's this is a string of binary numbers.
Okay, so because
I probably didn't need it. Let's see if I actually needed it. Nope, did not need it whatsoever. That was me overcomplicating.
Okay, because I remember the 2 means base 2, right? That means binary.
Yep.
Okay. Okay, cool.
Yep, that was totally me overcomplicating things. So ignore it.
Do you have to put the quotations there though?
Yes, because it wanted a string for some reason.
Okay.
Anyway, but that's moving on. That's beyond what I was trying to get at. Because the original question, why is bar, why does 2 bar get 4? Okay, so we've got a couple binary operators. So we've seen that. So there's a couple operations. Here, you've got your standard plus, right? So doing arithmetic like this is pretty good or pretty easy. How do I do 5 plus 1? Well, I do 1 plus 1 carry is equal to 0. Carry the 1, right? 1 plus 0 is equal to 1. Now, why did I do 1? Why is 1 plus 1 equal to 0? Carry the 1 because 1 plus 1 is equal to I'm just using idle. I'm just using a text editor. So 1 plus 1 is equal to 2. What is 2 in binary? It is 1, 0. So we put a 0 down here for the same reason we'd put a 10 down and carry the 1 for the exact same reason you'd carry the 1 and a 10. 1 plus 0 is equal to 1. 1 plus 1 is equal to 0. And there you go. That's pretty much what computers do all day long. They just add binary numbers or compare binary numbers. So you can do operations like that, but we also have access to other operations, such as the AND operation, which means only put down a 0 if there is if both numbers have a 1. Sorry, only put down a 1 if both numbers have a 1. So 0, 1 and 0 gives me 0, 0. And since both of these have a number, they have put down 1. And we can see that with 5 and 1 gives me 1. Okay. Or gives me is different. The values are not squaring themselves, not increasing of increments of 2. Yes, the bases are squaring themselves. So we start with 2 to the 0th, then 2 to the 1st, and 2 squared, then 2 third. We're raising the power, not so much squaring it. We're raising the power increases by 1 is much more accurate to say. I understood what you meant though. So the or means if either of the values have a 1, put down a 1. So there we go. Now we're up to 6. Oh, sorry, up to, nope, 5 or 1 gives us 5. 5 or 1 gives us 5. Listen to me, fingers, please, or 1. Now let's go and change this to 6. So this is 4 plus 2, 0 there, 4 plus 2 And if we did this, we would now get 7 as our output because a 1 in the 1's place, a 1's in the 2 place, and a 1's in the 4 place. Is this going to be on the test? Heck no. There is no, I never test on binary, but I mean, people were curious. So 5, so 6 or 1 gives us 7. All right. So that's binary. So it's like adding. They're just different operations that we can work specifically on these numbers. They work because we have very simple rules we can set up for just zeros and ones, because there's only there's only 4 combinations for any pair of numbers or any pair of digits. You've got a 0, you've got 0 0, you've got 1 0, you've got 1, sorry, you've got 0 1 1 0 and both ones. So those are your options for 2 digits. So that's why we have these other operations. You're never going to see, the next time you probably see them will be if you take a hardware class. So anyway, going back to this, so we have one more operation, which was the exclusive OR operation. So and the exclusive OR operation, let's do 6 or XOR 5. That's the exclusive OR. 6 XOR 5, because 4 plus 2 and 4 plus 1, 6 and 5. So exclusive OR is special. It says only put down a 1 if only one of the pairs are 1. So neither of these pairs are 1. Both of these are 1, but the rule is only one of them. 1 and 0. So we put down 1, and 0 and 1, we put down 1. So if we did 6 XOR 5, we'd get 3, which we see is 2 plus 1. So that's not what we'd expect. It's not exponentiation, which was what started this whole debacle of a tangent. So what is it? It is 2. So exponentiation is done like this: 2 multiplication signs in a row, which actually makes sense. Thank God. Because otherwise, because you know, it would be a mess if it was something more complicated, but it makes sense. Shortcut, you know, this is extra multiply, right? It's kind of this, or super multiplying. All right, so we can use it as the most advanced calculator. Now, what I was going to get into before I got into the tangent is that we can also do things that your normal calculator, your normal 4-function calculator can't. Give me a second. Come on. There we go. Got a button that just pulls it up, right? This is great, but it can only hold one thing by using these memory commands, which is rather silly. So we can create our own variables. X is equal to 4. Ta-da, like that. And we can recall that value. X is 4. I can then do any kind of expression I want. X times 14. What is 4 times 14? I have no idea. It's 56, apparently. Okay. We can set, and we can also, if we're done with it, we can set it equal to something else. We can set X is equal to 6, right? X squared is equal to 36. We can take that answer and store it in somewhere else. Okay. Is equal to X times 2, right? And we can get Y is equal to 36. All right. So now if you fell asleep for the last part of it, this is the point at which I need you to pay attention. Okay. Okay. This is the most important. This is the very first hurdle. Okay. Which it's all about this nemesis, the equal sign. It doesn't necessarily, it works differently than it does in math, right? So we just did X is equal to 6. Then we did X squared and got us 36. And so we did X squared is equal to Y. We stored 36 in Y. Okay. Now I said X is equal to 5. What is Y's value?
25.
36.
36. In math, you'd be correct, but here's the thing. The confusion lies in this symbol. This symbol over here, I've been saying equals, it is not the equal sign. There is no equal operation. There's an equality checker in Python, which will check if two things are equal, but this is formally known as the assignment operator, which simply says we've got a left side and we've got a right side. And what we're saying is that whatever's in the right side, I'm going to take it and store it on the left side. It might be better represented like this. Like an arrow, right? Take what's in the right and store it on the left, right? So if I said y is equal to 5, or sorry, y is equal to x squared, right? What you might want to think is like an arrow like this, right? Double equals checks for equality. Double equals is deals with Booleans. So is 5 equal to 4? False. It gives me true or false. It compares two values. It answers a question. But going back to y, again, this is kind of what we'd want to look at. If I was to store, so again, x is 5 at this point. And what I'd be doing with the equal sign is I'd be wanting to say, store 25 in y, okay? Store 25 in y. That's not going to work though, right? This or rather this value, or rather this expression doesn't really work. Why? Because we're conditioned to think of this somewhere else. Y is less than negative x squared. Well, what about this? Oh, that might work, but it's honestly a lot to type. Some other languages, I believe I mentioned this in lab, decided to use this symbol, which we lovingly call the Walrus Operator because it kind of looks like a walrus. If you tilt your head and look at it with little eyes with little tusks coming down. And that was just shortened to this. So because it kind of makes sense. So now y is 25. So what happens is that we compute what's on the right and we store it on the left. That leads to one very interesting consequence, which is I can do this. 5 is equal to this. X is equal to 4. X is equal to 3, right? Here's my consequence. And here's the consequence of this. I can create a completely legal statement and very useful statement in Python that we'll use a heck of a lot, but would be completely invalid and illegal in mathematics, which is x is equal to x plus 1. And what did that do? Well, x is equal to 3. So 3 plus 1, 4. So we evaluated what was on the right, and then we stored it on the left, which means that x's value is equal to now 4. So again, this is the assignment operator. And I go over a lot of videos about this, but the point of me bringing it up here is that it is super important. And it makes sense, and it starts making more sense when you realize we can do other things besides single letter variables and that. Now this is the third type that we use, which is string, which you were working with in your lab. Anything between quotation marks is a string. And we use that for when numbers are a bit too annoying for us to deal with. Time to blow a layer of abstraction away. Each of these is just simply like each letter is just a number in disguise. But I can't remember B's 98. That'd be really annoying, right? And to work with numbers all the time, that'd be hard. So again, we just simply pretend these are not numbers and use them. Other languages you can do mathematics with that kind of stuff, but Python doesn't want you to really do that kind of stuff. You can't add a string and a number. Although you can add two words together, which is interesting. And useful, actually. Very, very useful. Bird word. Makes sense. Fortunately. Right? Yep. The equal sign is called the assignment operator. But everybody just simply calls it the equal. So if you say assignment or equals, everybody's going to understand what you mean based on the context. Yeah, Birdman. Bird plus man would give you Birdman. Now you can't do subtraction for words because that's kind of ambiguous as to what you would want. Right? Which BI would I want to subtract from that? Right? Doesn't really make sense. And what do I do with words that don't have BI in them? That doesn't really make sense. Because we use the no. Okay, excellent question. So okay, two excellent questions. I have completely these. I'm liking these questions. These are good questions. The first question was, because we use the assignment operator to define variable, will Python let you accidentally assign multiple definitions to the same variable? And the answer is, it will let you overwrite definitions. So word will only ever equal to bird. As soon as I assign something else, it's going to be that value. It's only ever going to hold one value.
Wait, so I have a question. Remember that problem you did with assigning y to be x squared?
Yes, I did.
And then you changed x, but y remained the same?
Yes.
So does that mean it didn't, you changing x didn't override the y value? It
That's
just
correct.
stays, even though the x is different?
Right, because what happened here is that we computed the value and we took the computed value, not the x squared. We took the computed value, which was 36, and stored it in there.
Oh, so it stores it as
it's
36,
yes.
Not as 6 squared.
It stores it
not as x squared.
Exactly. That is exactly right. It's storing the computed value. You evaluate the operation on the right and you store it on the left. Again, I'll go into this in much more detail in the textbook and in the videos that I do that. Now, another question that was asked is, and yes, I see the chat. I swear I'm just going through in the queue. If the bird is an integer in disguise, can I int bird? Can I turn the bird into an integer? That is an excellent question. And I think I may have been, I can't do it like that because int is for turning things that we can logically turn into into integers. I could go through letter by letter and turn those each individually into a number and add 5 to it. And you can do math to stuff like that. I can do ORD. Again, this is won't come up. I can do ORD of A plus 5, and then I could do CHR into that, which turns that back into a character. So 5 letters after A is F. Yep. And Adrian, yes, correct. It always equals the most equal one. So yes, if you're not careful, we can accidentally overwrite our previous variables. Most of the time, you'll do it on purpose. Okay. Most of the time, you'll do it on purpose. Okay. Now, I know I've thrown a lot of information at you, and I apologize for that. I went off on a tangent, and then I went off on another tangent, and I went really quickly because I'm like, time. But so now that I've thoroughly confused you all, let's go ahead and take a look at our textbook. Okay, because now we understand that we can add variables and they can hold whatever we want. We can put strings in them. We could put strings in them. We could put numbers in them. What else can we put in them? Well, we can put things that are called objects into them. And objects are these pretty much everything is an object, but in this case, an object is something really powerful. It has a lot of commands. So let's just take a look at this code over here. And you'll find now this is a program that's actually looks scary, but if we read it line by line, it's not. And notice over here, the comments, they each explain what we're doing over here. We can save it and run it, and boom. Let me go ahead and drop this into chat for you so you can go to this web page, by the way. This is today's exercise. All right. That is today's exercise. Please look for it in chat. If you're not logged into Runestone, please log in so you can get credit for it. And if you aren't, or you haven't made an account, make an account at some point so you can get credit for it. Okay. So turtles are this wonderful learning tool. They were designed for a language called Logo for helping early learners of programming, as well as kids, to learn how to program in a graphical manner. And you'll see that it is graphic oriented. By running the code over here, created some graphics for me. I'm going to go ahead and reshare the screen so it's easier to see. So let's go through all this magic words together. Import turtle. The Python library is huge. I'll answer that question later. I want to work on this one first. Here's the link, dropped, boom. Here you go. So import turtle. So the Python library is huge. And if we make a bunch of Python programs, we don't necessarily want to load everything in. For instance, there's a library for web pages. We don't really need that unless we're dealing with web pages. So, and if we loaded everything up, it would take a long time for Python to boot up. So we don't, we just import what we need. So this one imports the turtle library that lets us use turtle. This is the only line of magic that is real magic. My turtle is equal to turtle.turtle. In fact, this is the only bit of magic. Turtle. So turtle refers in lowercase refers to this. This is the command to create a new turtle. And now that we are looking at turtle, the words turtle, just appreciate how weird it's spelled now that you see it repeated so many times. Turtle. Okay. Creates a turtle. And what this does, it stores it in this variable called my turtle. Now, my turtle.color. So now these are other commands. So this line over here, these are basically our magic. Everything over here is stuff that you can make sense of. My turtle.color green. So when we have an object, and this applies to strings, integers as well, each object comes with a bunch of commands, a bunch of verbs, a bunch of actions, a bunch of functions they can do. My turtle.color green. That one sets the color to green. If I were to change it to red, it changed it to red. Pink, blue. So I can change that color to whatever I want it to be. Turtle.forward 50. So what in the world is going on here? So the turtle program basically says, hey, I'm going to create a turtle. Let's say hi to him. Now this, if I want to copy out, comment out multiple lines of code, I can do so by putting 3 quotation marks around the block I want to comment out. That does nothing because I haven't really done anything for my turtle. My turtle is equal to, so my turtle dot forward, assuming I remember how to spell, move forward 40. So by default, it creates, it's colored in black. So what's going on here? Well, what we're doing is that we're looking down at this bird eye view of this turtle, which is represented by an arrow. Could probably do, we can do better than that. My turtle dot set shape, and how it works. but I need a turtle attribute has no set shape. Let's see. Turtle doc imitation. Here we go. Turtle set shape. Come on. It's just simply shape. My bad. Okay. Shape. Now we go. There we go. Much more representative of what we're looking at. See that we're looking at a bird's eye view of this turtle. Now he's on this giant white page. Okay. Now imagine this turtle is carrying around a pen attached to his tail. Okay. And so wherever he moves, this turtle drags this pen along the ground. So here, if I restart the program, he just moves. What is the number I'm putting in? This is the number of pixels, the number of pixels he's going to move forward. So he moved forward 100 pixels. And then we can give him other commands. I like these commands, by the way, they're pretty good. So let's keep going with these. But we'll keep them the shape of a turtle. My turtle is blue. Move him forward 50 pixels, which he did. Then this command, my turtle.up. Note the comment. It says it lifts up his tail, right? Remember, he's dragging a pen along his tail. So telling him to put up his pen up here, he lifts his pen. And so when he moves another 50, you can watch, he moves, he drags it and he moves it. I know that's fast, but there's ways to slow it down, but I don't want to overcomplicate it. I've already overcomplicated a lot today. Move forward, lift the tail, move forward again, creates this gap, right? So there it's been, there the tail has been lifted. Then here is another one. Oh yeah, you can make multiple turtles if you wanted to. Okay. So now this line over here, my turtle right 90, that makes him turn right 90 degrees. He was facing this way. So turning right means turning in this direction. So now that he's facing this way. Put down his tail. Then move backwards. And it's blue, it says green, but that's because I changed it to blue. That's why it's not matching up. So now if I did it in green, boom. There's all sorts of commands you can do with the turtle. Can you change the color of the tail without changing the color of the turtle? Yes. There's a lot of commands you can do with that. Turtle.color changes the pen and the turtle. Pen color changes the, I believe only changes the color of the pen. Instead, if you did that instead. So we could, let's test that out. Right. So there. Now to answer your question, we don't have to call this turtle. I often like, I like to do something like this. And Joshua, this might answer your question. I like to create my turtle and call him Bob often because Bob's a lot easier to type than my turtle. That creates Bob as a new turtle. And I can move Bob I can make Bob a red turtle. And then I can tell him to move forward 50 pixels. Turtle is the black magic. We'll be here for a lot. That is black magic. It gets answered in later chapters. But turtle, that is the code. This is the magic incantation that the writers of the turtle decided to do, that you have to do to make it. Okay. It has to do, but what it has to do with is that you're calling a package the first, but technically to answer your question, that for the turtle, the first turtle, the turtle dot, the turtle says turtle package, the dot says constructor. sorry, the dot says inside of, and this part says call the constructor, which builds a turtle. Alice is equal to turtle dot turtle. Where is it importing from? It's built into Python. So long as you have Python, you can use it. And I'll show you that in a second. So notice over here, Alice is equal to pen color as opposed to color. Let's see what the pen color is not defined. Alice dot pen color. There we go. And we see that we can have multiple turtles go walking around on here. Okay, so we can have multiple turtles going around. So what is today's activity? Even though I just blasted you with a ton of information, which if I'm recalling correctly, no. So yeah, I just blasted you with a ton of variable information. But yes, it is built in when you install Python. Today's exercise is I want you to try experimenting with this again. So I want you to try making a drawing, your own drawing in this second exercise. So this first exercise, boom, just draws that. So the rest of the exercise for today is to build this, is to draw your own turtle, your own diagram. I'm not really picky about what it is. I just want you to experiment. You can use the above as kind of your starting point. Now, to answer a couple questions that came up as well, just one last thing I want to answer, which is that I can do, and actually I need to set this up. So first off, I make a video about this, but since I've talked about turtles now, and some of you are going to try it on your computer, I need to let you know something, okay? So I can write import turtle, and that will work. And then I'll say Bob is equal to turtle dot turtle. Bob dot forward. And I want to, and I'll move him forward, let's say 100 pixels. So I'm going to run this. The first thing it's going to prompt to say, I need to save this. Okay, there is, and in saving it lies our trap. Okay, because you might be tempted to name this turtle because you're working with turtles. Okay. Yeah, amazing how repeating it makes it not seem like a real word. All right, so you might be tempted to name this thing turtle. Do not under any circumstances name it turtle. Okay, because that will make your computer really confused. I have videos on that later. If you do that, the solution is to delete the file or rename the file you just made. Again, that's covered in chapter 4, but it's a super common mistake. So I'll just simply call it like drawing test or something. And now we can run it and see, it says, did you mean forward? Yes, because I am bad at spelling. There we go. And it works. And it moves really quickly. Okay, so go ahead and write your own turtle. And yes, somebody else pointed out in chat is that one of the things you can do is that we can do something like this. Alice you can create circles using circle, which is pretty cool. And another cool thing that you can do with circle, if you want to try some drawings, is that you can put in a second number, which says, I want to approximate a circle with this many sides. Let's see, does it work? Huh, why isn't it not working? I thought it would do that. Do I have to have 3 in there? Ah, there we go. You're just going slow. So ignore what I said. Apparently, I need to figure that one out. Pretty sure that. See, turtle, circle. Circle. Go. Extent is equal to, so it should be. Oh, okay. Now, sorry. I got my order messed up. So your second number is the number of degrees of a circle you'd like to do. Got my orders messed up. That was all. And the third one is how many sides to the circle, which is a very confusing question. How many sides do you want it to do? But you notice that this half circle is made from 1, 2, 3, 4, 5, 6, 7, 8 sides. Similarly, you could do this. Because remember, you can't actually draw a circle. It's actually impossible to draw a circle on your computer. And zoom in and you see why it's made. The circle is actually made of squares. That's why it's impossible to draw it. Circles about covers it, but you can we'll eventually learn to program them in on our own. So go ahead and play around with it, and then you are done for the day when you finish that exercise.